Just gave it to you.
Okay, no, I can encode. That's fine.
Perfect.
Okay, that's fine.
Okay, so we go back to my screen, or someone else wants to try?
Yeah. You're just doing the last step.
Okay, so all right. So we were here. So the outer loop, as Brandon said, it's we're going for the full length of the array. Okay, minus the last element we should go. And in the inner loop, each time we have to go one more than the I up to the length of the array. Okay. So we have to calculate how many times we want. So maybe here it's num's length -1 because we go to element before. And this one should be I.
You can create a variable and just say j equals I plus 1.
Yes.
If you want to keep that.
Yes, but I will put it where? Because I can say nums.length plus I times, but it will start from 0 again. Okay?
That's the problem. I sent something on the chat, which
So we have to do arrange something to start from.
Yeah, maybe within
look,
each statement, each with index.
Because,
yeah, he's doing another one. Try that one.
Okay, so my Ruby is a little rusty. That's why. So
check on the chat and try Ayman's solution.
Brandon. Okay. So yeah, I'm taking the chat. All right. Someone has posted something.
Not the Slack chat, the Zoom chat. Sorry.
Oh, the Zoom chat. Okay, sorry. All right. So this is what we want. Copy. Okay, so.
Dot each, and then it should be each with index, I believe. Instead of that. Then underscore with and then index after the dot each.
Okay. Yes, we want to do it like this with underscore index or a one word to index.
No, index, but index is not capital. It's just it's all right, like that underscore. Yeah. And then instead of j, you can give it value /j, because the first thing that it takes is the value of the thing that you're passing.
Okay.
Actually, no. If you just sorry. If you just do j, if you just leave j, I think it's gonna work.
And you say to do this instead of the line 5 and all of it, or inside?
No, just on the line 6. No,
Okay.
you can remove the each with index. Just keep each and then j, because this is not an array we're looping through. We're just looping through numbers. So
yes.
that's gonna be.
Yes.
Yeah. Okay. So is this going to work? Maybe.
We will see, because I put the test. We were failing. Okay, so we're still getting 0, 0. Okay, so what is?
So why is that?
I don't know, guys. I don't know.
Okay, it can be because the first I we are assigning is a 0, and if we try to go in one step behind in the line 6, it should be something more than I.
Yes.
So it could be.
It should be I plus 1, right?
Yes.
Yes.
1, 2.
Okay.
But this one, I don't
parentheses.
know if I needed more parent here. Okay. So. Okay.
It's a long time. No. Put the -1 after the nums.length, because now we're searching for an array that's not there. We're searching for num_j, the very last step, which is not there.
Nums length is the last j we want to check.
I don't think so, because nums.
No, you need one before.
Array, it starts from here.
All right. So in the outer loop, I need 2 before, but okay, let's check it.
It can be that in the first one you need 2 before, yes. Oh, accepted this one.
Okay, but I don't know if it will work in but yeah, okay. So if there are numbers, which there are, it will never go to the.
Why are you using the times in the 5th row? I don't think we're gonna need time like the -1 in it, because the times, what it does is it goes through each and every element. However, if you say dot length, it just takes the size of it. So I think at line 5 we don't need the -1. I'm not sure.
In reality, we don't need it, because it will never go to the last item. It will find the solution earlier. Okay, because there is a solution always. So in this case, the solution is the 2 the final two elements. So the outer loop stops here in the 2, and the inner loop finds the 4 and exits, returns the values. So, yeah.
Okay, let's test it. Let's see.
So Sergio is the one who's helping me more.
No, because is this faster? I don't think so.
Okay,
We will
submit
see
it.
now. But now
I
it says
doubt
wrong
it.
answer. No. Oh, no, it doesn't. Did I submit it? No, I submit. Okay,
It's
sorry.
a wrong answer. Okay, no.
Yes, no.
Wrong answer.
Yo, no, it's correct, but it takes 2,000.
Why? Whoa! Why?
I don't know.
Because I don't know. We are doing at times.
So,
No one each.
Yeah, maybe that's the thing. Like we're getting the length and then we're making a range. So for example, on line 6,
but we're giving a range, okay? So this happens once. So it says nums length times, so it gets the length once and does it so many times. You don't check the nums length every time. It doesn't check the length, so it's not the problem. Probably the connection, probably the thing. I want to copy the code and try to submit it yourself to see the numbers.
Yeah, let's do that. Let's do that. I
Okay,
send it in
so
the Slack.
Okay.
You're terrible. I know that whiles can be better if you know your constraints or if you have a specific constraint. Not in this case.
Okay, so maybe let's test it out.
This one is TwoSum, no, from LeetCode.
Okay, did you get it? Yes. TwoSum from LeetCode, yes.
JavaScript.
No, we're trying Ruby now.
No, it's Ruby, right?
Yeah. So I thought I forgot. Where is it? Okay, so Braddon had to go and says, okay, so we have to go. Let's see what happens. We do it all the time, but sometimes we got.
No, it's the same for me. I'm getting like, if I can share my screen.
Yes, of course. Yes. Okay.
So this is the same thing. This is the algorithm that that we're using. This is like the this is the normal one that you talked about. This is the hash. So of course this is like a big improvement. The memory is not improving. If I'm using hash or I'm using let's look at them. But yeah, this code is taking 2,000, so it's not just your connection. Like my connection is bad as well, but
I think the times is not a good solution. Maybe we should try while loop or something else, but in the next.
Yeah. Maybe instead of loop, we can do it in JavaScript, which is easier to understand.
Yeah. Okay, it's a matter of familiarity. So I'm starting again to write Ruby code just to get, because I'm rusty. I don't remember things. So I think a while loop might be faster, but the for loop definitely is fast. That's why I asked, I think it was Sergio, if you had timed it. I think I asked you if you have timed the difference between a while loop and a for loop.
No. I just remember that once that I did that problem. I had to search. Yeah. And somebody said to move it to a while loop as we knew the size, the maximum size to be taken. So
we should do a timing someday.
So last thing, I think, because like 1 hour is almost up, I wanted to just show the implementation of the Ruby hash method that Nick showed us in JavaScript.
Yeah. All right.
So here we have created a hash map, which is just an object that Ruby gives you. It's a special type. And then we're iterating through it, and we're getting the difference of that we want. Can I just show this in here? Okay. So as Nick was saying, we go through each and every element here, and we get the difference from the one that we want. So for example, in here, if I'm searching for, like at the first element, I'm comparing 3 with 6, and the difference between them is gonna be 3. So I'm saving this 3 in this hash map. Okay, so I'm saying if I don't have the difference, if it's nil, just save it. Just save it in the hash map as a new item. So then I go to the next one. I go to 2. So what's the difference between 6 and 2? It's 4. So I'm saving the hash map here. So the hash map this time has, after this step, has 2 items in it. One that has a value of a key of 3. No, sorry, it has a key of 3 and a value of 0, right? And
Right.
the other one is gonna have a key of 4 and the value of 1, because I'm storing the
Index.
the value and then the index. So the idea is that when I get to this one and I'm searching for it, like the difference between So I get to this item and I can see that I already have this item in my hash function. So what I do, I just return the index of this, and this is of course much faster than the other one. But what I wanted to show you as well is that in Ruby, at least, the memory difference between the 2 for loops, one inside of the other, and the using of the hash map, even though you might think that the hash map takes more memory, it's actually taking the same amount of memory. So I'm not sure why that is. Like as Nick was saying, you would expect it to take more memory, and in exchange it would run faster, but it's taking the same amount of space. So I don't know why that is.
I think probably it's because the tests are with small arrays.
So if it was like with a much bigger array, it would then show, slowly, maybe.
Or the solutions are too early in the array. Okay, so it's not the last element of a 10,000 element array. Probably because of this, because there is a difference. You see, there's a difference of 0.4.
Yeah, it does make sense, because in the second one, you're actually creating an item and you're saving each and every item in it. And as you said, in the worst case scenario, you have to go through each and every element and actually save it. So, yeah.
All right, perfect.
So do you guys have any suggestions for maybe next week's meeting? Any challenges that you'd like to go through?
I think we spent the whole time with this one. I didn't see the other one, the 2 linked lists.
Yeah, but I don't think we have enough time. I can go through it if you guys want.
We can do it for the next time if you like.
Yeah, we can keep it for the next time. But do you guys have any other one that you would like to go through instead? Any suggestions?
Okay, I'll think about it, and if I have a suggestion, I'll write it on Slack, all right?
Yeah, for sure.
This is something that
Ayman, how about this tower thing you wrote article about? Maybe
I was gonna say similar, the thing of Hanoi, because
Hanoi tower.
I mean, it's the whole concept. Pretty much Hanoi is used to explain recursion on the whole level, pretty much. I mean, that's what they use Hanoi for.
Yeah,
that could be interesting.
Yeah, it's interesting, this one. Yeah.
Okay, if you guys want to go through it, maybe try and implement your own. But the thing is, we already did go through the Tower of Hanoi problem in a previous meeting.
Okay.
Yeah, and it's in the meeting. So if you guys want to go and
where are those recordings available?
It's in the what's it called? It's in the repo. I'll send it in the Slack. I'll send it in the Slack. Yeah. So,
yeah. Okay.
Is there a YouTube channel?
I'm fine with going back to it if you guys have a different way of solving it. Of So what do you think? What should we do? Should we go through the Tower of Hanoi again, or should we go through this one? What's it called?
I don't see a
merge through sorted arrays.
Yeah, probably let's do new thing. If we have recording for Hanoi, we can just touch it.
Let's go to something new.
Yeah.
Okay, linked lists. Okay, and something else. If you if you think something else, we can write it on Slack and.
I'd actually prefer not to
Okay,
go
check
through
it.
the linked list one because it forces you to use a linked list in the way that they wrote it, which can be quite annoying. Yeah, so like just put any suggestions during the week because I really don't want to go through that. It's not difficult to solve. It's just like annoying and it takes a lot of time. So I'd like rather want to avoid it if possible.
Okay, okay.
Yeah. So this
Okay,
is
so it was nice
the
to talk
link
to you guys.
in the Slack. Yeah.
Nice to talk to you. I have to go because I have a meeting in 10 minutes.
Yeah. Take care, man. Take care.
So all the
Thanks
best.
a lot, guys.
To you too.
you.
Have a nice week, everyone, and see you Monday.
Yeah. See
Thanks
you.
a lot, guys.
Bye,
See you
everyone.
Monday.